So let's talk about what Impact is solving. And to understand that, we first need to talk about management of state in React itself. Like, why isn't React enough to manage state? And one important aspect of this is not state management in and of itself. It's having state management shared between different pieces of UI. So if you think about React and its state management, it's actually scoped to a component. All the primitives you use for defining state and managing that state, that's contained within a component or defined within a component. So if you want to share state or management of that state, you have to pass it down as props to children. And as complexity increases, you've probably noticed that you get into this world of props drilling, where you have one component that needs to manage state and define the state, and then you pass it down as a prop to an immediate child. But then that child just passes that state or management of that state to yet another child. Doesn't really care about the properties, it's just passed down. Or maybe you've been in the situation where the component that's really responsible for the state and related management needs to move up to a parent component because you have a sibling component that's also interested in some of the state or management of that state. Now, to get around this in React, you would typically create a component that defines a context provider. So you can expose state and management of the state on a context value that can now be consumed by any nested component at any level. And that conceptually makes a lot of sense. But since the way React works with its reconciliation loop, there is a challenge having a context provider, because how you expose this context value matters. So for example, if you were to expose some state and management of that state, you might choose to use an object on the context value. But now if a parent component of the component responsible for the context reconciles the component responsible for the context, it will actually trigger a reconciliation on any component consuming that context, because the object reference changes every time the component or the provider component reconciles. And you can fix this by using Memo, for example. But the biggest challenge with these context providers is that the consuming components can't select what they actually want to consume from it. So if you have a provider component that has a lot of state in it, and you have a component that's only interested in a small piece of state, that component will always reconcile regardless of what state is changed within that context. And this can be solved by splitting up into multiple context providers, but then you have to be careful about the order, because if one context provider wants state or manage state from another context provider, you have to ensure the order and so on. So when you reach a certain level of complexity, this isn't a great way to share state and manage and share the management of that state. But we do have solutions for this already. So if we talk about the state itself, we have this concept of global state. And we use primitives like atoms, signals, reducers, or observables, which basically are the same thing. They encapsulate some piece of state, and then you're able to change that state. You can get the state, and you can also subscribe to the state to know when it changes. And these are different implementations with different flavors of API, but fundamentally they work the same way. But the thing is that the management of this state happens in components. So you're not able to move the management outside of the UI. So sharing the management becomes problematic, and you just have all these state primitives floating globally around in your application. So what we built was something that commonly is called global state stores. And what they do is that they take these state primitives and put them into a structure. And that structure is typically a tree, a single global tree, that being represented by classes or like an object. It doesn't matter. It's a tree. And some of them, they allow you to implement management of that state directly into the store, while others have a management layer on the outside. Like for Redux, you have Thunks, for example. And some of them, they don't allow you to implement any kind of management of the state. That still happens within the components. So as you can see, you would expose these stores at the top of your application. So they're typically defined globally and consumed globally. And any component can use the state and optionally management if they provide exposing management of that state. And this is great. Like I worked on a couple of projects that exposes state and management in this way. And it solves a lot of issues of sharing state and management of that state. But having just one big representation globally of all the state and management of that state actually has some challenges. So let's talk about how Impact works differently. So Impact is also based on a store, but it's not specifically like a state store, and it's not one global store that you expose to your application. Impact has multiple stores, so you rather think about what state and management of state do I want to encapsulate into a store, and then you just implement it in that store. And you do that by defining a function. So a store is just a function where you return the public state and management of that state that should be available to components or other stores. The great thing about using a function is that whatever you don't return from the function, that becomes private. When you want to compose these stores together, you actually use a common pattern you know from React, which is the hooks pattern. So as opposed to having like classes that you need to instantiate and pass into each other to compose state and management of state together, you can actually just use the stores within each other, just like you know from the hooks pattern in React. You can choose if these stores are to be exposed globally or on a specific componentry that representing a page or a feature. The stores themselves, they can be completely empty. You can just return nothing, and that's a valid store. But typically you would implement some state and maybe some management of that state from the store. But you're not forced to do that. You have a lot of flexibility in what your stores are going to do. Another important aspect, if you do expose a store on a component tree, it becomes tied to the lifecycle of that component tree. So that means that it instantiates when the component tree mounts, and you're able to act on the unmount of that component tree to clean up like subscriptions or whatever you might need. So as I said, a store in Impact, they can return basically anything. They can return some state and management of that state. They can just return some state, or they might just return some management of state from another store, for example. If we think about this in the context of React, we could have a store A and a store B. And by default, you don't have to provide these stores to React. They are registered globally. So in this case, store A is being used by store B. And any component can now use either store A or store B, where, as I said, store B is using store A. But you will quickly see that it's beneficial to be able to provide certain stores to, for example, a page or a specific feature. So in this visual overview, we still have store A and store B, where store B is using store A. But we explicitly expose these globally by putting a stores provider at the very top of the application. And then any nested component in any component tree can use store A or use store B. But then you might open a certain page, and that page is wrapped by its own stores provider, which has store C. And since store C is exposed through a stores provider, you can actually send initial data to that store to instantiate it. And as mentioned, store C can use other stores. So in this case, it's using store B. And now any nested component on this specific page can still use store A and store B, but they can also use store C. So now you get like a mental image of how these stores can be separated and composed together, and how your UI can still be scoped to certain state and management of that state. But you're also free to have global state and management of global state. So this is how Impact differs, and please watch some more videos to get more into code and seeing how you solve specific problems.